Okay, so this is question number 20 from your review. So please stop the video and try to do it on your own. All right, try to figure out what are the key words here. What is the information given to you in this video, right? Okay, so let's see what is the most important thing here to figure out. So they are talking about teacher salary, and the thing that they are saying the word here average. All right, and this is the amount of the hours, right? So it's 57,337. All right, dollars. So then that's the first thing that you need to know, that the average is 57,337. The second important thing is that they are talking about the distribution of the salaries is normal. So they are not saying standard normal, it's just saying normal. So you are not working on the z-axis, you are working on the x-axis. All right, and as well they are giving you standard deviation. So standard deviation is 7,500. All right, so then they're gonna ask you that assume that the sample is taken from a large population. This means those values are basically accurate for population. All right, and we're gonna be using the calculator in order to solve this. All right, so again, I think the best way is to graph it, understand what are these values, and the question is, in the end, is to find the probability of the x's, all right, less than $51,000, all right? So, okay, so let's go to the whiteboard, right? So we have here a normal distribution. And as usually going to be a bell shape. So we have a bell shape, a nice bell shape, not a triangle. The middle here is going to be the mean, which is $57,337. And we have as well the standard deviation, which is 7,500 or 7,500. Now, we want to figure out, as we mentioned earlier, so this is a normal distribution. Every time you are using only normal distribution, not a standard normal distribution, so it's missing the word standard. So this axis over here is going to be the x-axis. All right, so now the question, which is A, is looking for the probability of x less than $51,000. all right, so what we need to figure out where is the x located at, and in order to do that, so if this is the middle here is 57,000, around 57,000, so 5,100 is going to be 51,000, it should be here. So this is, I'm going to call it x1, which is $51,000. okay, so then right now, how I'm gonna figure out that x is less than 51,000. That means I am less than 51,000 over here. So whenever you are asked about the probability, again, you are being asked about the area of this vertical line here on the 51,000, the horizontal line going on the x-axis, and then you curve it from the bell shape. All right, so you are looking for this area in here. All right, this is the area you are looking for. In other words, this is the probability. The area here is equal to the probability of x less than 51,000. okay, so now I think in the class you learn how to do this with the table and the formula. However, if I want to do this with the calculator, is way easier. So what I need for in order to use the calculator, I need a couple of things. So the first thing is I need this information over here, the mean and standard deviation. And as well, I need the upper bound and lower bound. Okay, so what are the upper bound and lower bound? So obviously here, this is the upper bound. So this value here is the upper bound. Now, what is the lower bound of this area? The lower bound is obviously going to be here going all the way to minus infinity, right? So the lower bound again be minus infinity. And you remember what is minus infinity called on the calculator, right? So on the calculator, we're going to put minus 1 e to 99. All right, so this is going to be my lower bound. So I'm going to start to calculator, and then I'm going to go to second, and then vars, where the distribution is in blue. So I'm getting into the distribution mode. And then the first one is normal PDF. We never use that one. Sometimes we use number 2, which is normal CDF, whenever we are looking for the probability. Okay, so we are using number 2 in here. So this is how you get the probability. You're going to enter this. So the lower bound is by default minus 1 E99, and then it's fine. You keep it as it is. The upper bound here is 51,000. So you're going to type in 51 and 1,000. 1, 2, 3. And then the mean, make sure that you input the mean that you have on the problem, which is 57,337. And then standard deviation here is going to be 7,500. Okay, I think everything is set up already. So enter and enter again. And then it's going to be minus 1.9907. So the area here, or the probability if you want to. All right, so this answer is going to be 0.19907. And I think you need 4 digits, so probably gonna be this. I didn't read it, but you have to round this, right? So if you round it, it's gonna be 0.1991. Okay, that's it. So let's go and plug it in and see. All right, so here they are saying in this question they wanted to round your answer at least 4 decimal places. So you're gonna be 0.199 and 1. Let's check this. Yep, that's good. Nice. Okay. Now the second part is asking you to figure out if the sample size right now is 55 teachers' salary, right? And what and we are looking again for the probability, but here they are asking you for P of X bar equals to less than $55,700, right? So now do you see the X here and the X bar, it changes, all right? So we are asked totally different questions. And here, how do you know that you are in different mode? Because they are telling you about the sample. All right, so before they never told you about the sample. Right now they are telling you about the sample, right? So every time they are telling you about the sample, you are using the central limit theorem. All right, so let's go to the whiteboard and try to do it. Okay, so what is the central limit theorem? All right, we have a distribution, any distribution really, all right, and we are doing a sampling. So we're gonna take samples from here. All right, so the sampling, it happened that the n here sampling is equal to 55. All right, so regardless of what distribution here, it happened to be a normal distribution, is not necessarily to be normal. However, every time you do a sampling, you are doing like 55 at once, right? You are sure that your new distribution will be a normal distribution. So this is a fact, right? This is the central limit theorem. Central limit theorem. All right. So according to the central limit theorem, this, okay, do you remember here we used to have x, right? We used to have x as an axis. Whenever we do the sampling, this x will become x bar. So my new axis is called x bar. The mean, the new mean right now is called mu of x bar, all right? So this is the new mean, and it happened to be that it's exactly the same mean as before. So if it is the same mean, we know it's going to be 57,337. So this we know is going to be 57,337. Now the thing that you're going to change is the sigma x bar, so the new standard deviation. In fact, according to the central limit theorem, it's going to be the old sigma divided by radical n. All right, so the new standard deviation is going to be 7500 divided by radical 55. So now we have a new distribution, which is as well normal distribution, and we have a new mean, and we have a new standard deviation. Right, I did not calculate it, so I don't need it for calculation. So the values, as long as you know the values what they are, that should be enough. Now, okay, so the question is, what is the probability of x bar is less than 55,700? So we are talking about x bar. So x bar, definitely we are in here in this graph, and this is the x bar, right? So if I know right now this value here is 57,000, right? So 55,000, it should be somewhere behind it, right? So this is the new x bar. I'm gonna call it 1, which is 55,700. So I am in this point, and I am looking for x bar less. So x bar is less, you're gonna go this way. And again, it's a similar thing you're gonna do is you are drawing the area. All right, so you're looking for this area in here smaller than 55,700. All right, so this is the probability that you're looking for. So this area here is the probability. So how can I do it? Again, it's exactly the same thing. So we need the mean. We have it. All right, so this is the mean. I got it. I got the standard deviation. I got it for my calculator. I will need the lower bound and the upper bound. Obviously, this is the upper bound. So this is my upper bound here. And the lower bound is going to be somewhere here if you keep going. So lower bound is going to be the minus infinity, which is -1 E99. All right. And the area, obviously, the area would be extended all the way here, right? So this is what you need for the calculator: upper bound, lower bound, and the mean and sigma. All right, so let's see how can we do it. It's exactly the same thing. So I'm gonna go to the calculator. I'm gonna start with second distributions, and then I'm gonna go to number 2 because I'm looking for a cumulative distribution function, so CDF, and then I'm gonna enter. So now the lower bound is the same. I'm not changing it. The upper bound, definitely I have to change it. So this again, you can clear it and type in 55,700. Okay, and then the mean, it stays the same thing, 57,337. So you keep it as it is. However, here the standard deviation is gonna change. So the only thing you're gonna do is divide that standard deviation. You're gonna divide it by, no. All right, let's clear it. So 7500, you divide it by the square root, which is second and squares here. That's the square root, and 55 inside. You don't really need to calculate it again. Don't make any approximations. Keep it as it is, right? And then you're gonna go paste it and enter and look for the probability. So that's the probability. You need to round it to 4 decimal places. Alright, this one is supposed to be 0.05275. So I need to round this one, so it can be 0.0528. Alright, so that's what I'm going to put in my answer. And let's check it. Nice, we're done then with 20.